The problem considered in this video has a hidden trap. Try to identify the trap and find the right solution of the problem. This will enhance both your critical thinking skills and understanding of the role of friction in the motion of objects. Let us consider a steel block which can move on the long aluminum incline with angle of elevation 28 degrees. The motion started at time t equals 0 at point x0, and the block must arrive to the point xf at time tf. What has to be an initial velocity of the block? One of my students, her name was Kelsey, suggested a plan how to solve this problem. First, she considered two scenarios how the object can move from initial point to the destination point. In the first scenario, the object starts at the initial point and moved down along the incline and arrive at destination point. And during this scenario, object was moving under the action of two forces. Force F parallel, which was a net force of gravitational force on the object and normal force, and force of kinetic friction, which pointed in opposite direction to direction of motion of the object. The net force generates acceleration a1, which one can calculate using a second Newton's law. Next, she decided to calculate the largest time the object spent during this motion. To do this, she used a well-known equation of kinematics, which with initial velocity equals 0. So she was looking for largest time. After simple calculations, she got the answer t equal to 74 seconds. It is the largest time to reach destination from initial position moving down to destination. This time is less than the time given in the problem, and for this reason scenario 1 is not appropriate to solve the problem. According to second scenario, object starts to move upward the incline with initial speed v0, of course pointing up. So object moves up and arrives at the point which we will call U-turn point, and at this point the speed of the object is equal to 0. During this motion, the force of kinetic friction will point in the same direction as F parallel, and they both provide acceleration a2. After this, the object moves downward and arrives at point of destination. During this motion, force of kinetic friction is opposite to the force which was previously, and acceleration a1 will be different from acceleration a2. It means that this part of the path up and the path down should be considered separately. On the basis of this analysis, Kelsey suggested the following plan to solve the problem. As a first step, she suggested to find the time to reach U-turn point. The answer will contain a known speed v0. Second, to find the time to reach destination point starting at U-turn point. with zero initial speed. Next, she took into account that the sum of these two times should be equal the time given in the problem. And solving this equation, we can get the value for V0. Everything looks good, but unfortunately this plan is incomplete. Something important was not taken into account. Try to find a missing part, and as a hint, think about two kinds of friction. If you need help, the links to help resources you can find in description for this video. A link to the complete solution to the considered problem you can also find in the description for this video. There you can find links to short lectures on kinematics which can be helpful for understanding the solution.